We have now covered the review of numbers, the number line theory, how to perform addition, subtraction, multiplication and division operations with integers, and we've also covered BODMAS. Let us now look at the properties of operations on integers. Now we'll look at the closure, identity, commutative, associative and distributive properties of addition, subtraction, multiplication and division. This table shows which operations satisfy various properties. In this table, x, y, z are supposed to represent sample integers and k, capital K, is the set of all integers. What are some of the properties that we are studying? The properties that we are studying are commutative property, associative property, identity, closure and distributive property. And we will study these properties with respect to the operators addition, multiplication, subtraction, division. And the set of the numbers that we are interested in are integers. So for instance, the addition property satisfies the commutative, associative, identity and closure properties. Multiplication also satisfies these four properties. However, subtraction does not satisfy commutative property, it does not satisfy associative property, it does not meet the identity property. Division does not meet all four properties. Distributive property is something that we will discuss in the subsequent slides. Distributive property is satisfied only by multiplication over addition and subtraction. Now let us look at what commutative property is. Commutative property basically means if you have two integers that are being added with each other, even if you change the order in which the integers are added, the result will still be the same. This is true both for addition and for multiplication. To understand these different properties, let's start to look at some examples. We are now going to replace the x, y and z values that you can see in these equations with some sample integers, and we will see whether these properties are satisfied by addition, multiplication, subtraction and division. So let's modify this table a little bit and replace these by actual integers. So the x is replaced by 8 and the y is replaced by 3. So the commutative property looks like this: 8 plus 3 on one side and 3 plus 8 on the other side of the equal to sign. Are these two equal? Yes, they are equal because 8 plus 3 is 11 and 3 plus 8 is also 11. Similarly, 8 multiplied by 3, is it equal to 3 multiplied by 8? Remember, you are taking two integers, you are multiplying them, but then you are changing the order of the multiplication. When you change the order of multiplication, the result does not change because 8 into 3 is also 24, 3 into 8 is also 24. Now let's get to subtraction. Now in subtraction, the commutative property can be studied like this: 8 minus 3 on one side and 3 minus 8 on the other side. Now what is 8 minus 3? 8 minus 3 is 5. And what is 3 minus 8? 3 minus 8 is minus 5. Now 5 is not equal to minus 5. And according to commutative property, even if you jumble or reorder the integers, the result should be same. But because of when you reorder a subtraction, the result is not the same, and therefore subtraction does not satisfy commutative property. This is also the same case with division. If you reorder the digits that are involved in division, the result is not the same. 8 divided by 3 is not the same as 3 divided by 8. Now let's look at associative property. Associative property states when multiple integers are involved, not just two, but more than two integers are involved, even then associating an addition or the numbers with certain sequences should still not change the result. So for example, let's take 8 plus 3 plus 4, where 3 plus 4 are placed in brackets. Now similarly here 8 plus 3 are placed in brackets and 4 is outside. So according to BODMAS, you will have to do this operation first, 3 plus 4 first and then add it to 8. And the answer will be 3 plus 4 is 7. 7 plus 8 is? Yes, 15. Now, is it the same as the relationship? Is it the same as the equation on the right hand side? Let's see what is the equation on the right hand side. It has 8 plus 3 in brackets plus 4. So according to board mass, you have to solve this first. The 8 plus 3 in brackets. 8 plus 3 is 11 and 11 plus 3 is 15. Now are these the same? Yes, they are the same. Similarly, in the case of multiplication also, we will find that multiplication, changing the order of the multiplication does not change the result. So multiplication and addition follow the associative property, but subtraction and division do not. Now let's look at each of these properties in more detail. Let's look at the closure property. The word closure is related to the theory of sets in mathematics. It says that if you take two integers and perform a certain operation with these two integers, the result should still remain an integer. If the result still remains an integer, then that means that operator satisfies the closure property of integers. So for example, let's take the integers 8 and 3. What is 8 plus 3? The answer is 11. What is 8 minus 3? The answer is 5. What is 8 multiplied by 3? The answer is 24. So if you perform the addition, subtraction or multiplication operator on 8 and 3, the answer is a number which is also belonging to the same group as 8 and 3. That means the result is also an integer if the input is an integer. So if you are taking two integers and adding them, the result will also be an integer. If you take two integers and subtract one from the other, the answer will also be an integer, and so on till multiplication. If you multiply two integers, the answer will also be an integer. But what about division? What is 8 divided by 3? The answer is 8 by 3. Now 3 cannot divide 8. Therefore this is a fraction. So the first three operators resulted in another integer, but the division operation resulted in a fraction. In fact, you can take any two integers and subject them to addition, subtraction or multiplication. The answer will always be an integer. But that is not true of division. Therefore, we say that the set of integers is closed under addition, subtraction and multiplication. Or rather, the addition, subtraction and multiplication operators for integers satisfy the closure property. But the division operator for integers does not satisfy the closure property. The commutative property means that even if the order of the integers is changed in an addition, subtraction, multiplication or division operator, the result should remain the same. So let's take example numbers 3 and 6, right? So in addition, if you add 3 plus 6, the answer is 9. If you add 6 plus 3, that means you are reversing the order of addition, the answer is still 9. And this is in fact true for any two integers that you pick. Adding any two integers in whatever sequence will give you the same result. Let's see what happens in the case of subtraction. 3 minus 6 is minus 3. And 6 minus 3 is 3. So obviously you can very well see that in the case of subtraction, if you reverse the order of the integers, the result is not the same. Therefore, the subtraction operator is not satisfying the commutative property. In the case of multiplication, 3 into 6 is 18. 6 into 3 is also 18. In fact, if you take any two integers and multiply them, even if you change the sequence of multiplication or the order of multiplication, the result will still remain the same. So the multiplication operator for integers satisfies the commutative property. Now in the case of division, 3 divided by 6 is the fraction 3 by 6. 6 divided by 3 is the integer 2. Therefore, 3 divided by 6 is not the same as 6 divided by 3. So if you change the order of integers in the case of division, the result is not the same. So the division operator does not satisfy commutative property. Therefore, commutative property of integers is such that the plus and the into, that means the add and multiply operators, satisfy the commutative property, but the subtract and divide operator do not satisfy the commutative property for the set of integers. What is the identity property? The identity property has its basis in the definition of something that is called an identity integer. Now, what is an identity integer? When you take any integer from the number line, that means you pick any integer number and you perform one of these operations, the addition operation, the subtract operation, multiply operation, or the division operation with the identity integer, then the result should be the same integer that you had picked from the number line. So what does this mean? For example, let us consider the addition operator, and let us assume that the identity integer is the 0. Now 0 is also an integer. Now let's randomly pick a number from the random number line. So let's pick 8. What is 8 plus 0? The answer is 8. And what is 0 plus 8? The answer is 8. Both results are equal, and they are equal to the random number that we have picked, which is 8. Now because 8 plus 0 is also 8 and 0 plus 8 is also 8, and 8 was the number that we had picked up, we can clearly say that 0 is an identity integer. Even if you add 0 to any other integer and you jumble the sequence, that means you change the sequence of addition, the result will still remain the same. Therefore, the identity integer for the addition operator is 0. Now let's take the subtraction operator, and let's assume that for a minute the identity integer is 0. Now what is 8 minus 0? The answer is 8. What is 0 minus 8? The answer is minus 8. These results are not equal. In fact, if you replace 8 with any number, 17, 6, 25, 102 and so on, and you perform these operations, 102 minus 0, the answer is 102. 0 minus 102, the answer is minus 102. These two results are not equal. Therefore, 0 is not an identity integer for subtraction. In fact, pick any number or any integer instead of 0, and you will see that these results are not met. This and this will not be the same no matter what integer you pick as the identity integer for the subtraction operator. Therefore, the subtraction operator does not have an identity integer. How about multiplication? In the case of multiplication, if you multiply an integer with 1 and you change the sequence of multiplication, that means you multiply 1 with any integer, the result will still remain the same. That means both results are equal, and they are equal to the original integer that you had picked. So that means 25 into 1 is also 25. 1 into 25 is also 25. 102 into 1 is 102. 1 into 102 is also 102. Therefore, even after jumbling the sequence or reversing the sequence, the result is still the same. Therefore, the identity integer for multiplication is 1. Using the same analogy as for subtraction, if you take any identity integer and you apply the division operator on it, that means, let's say we took 1 as the identity integer and we did 8 divided by 1, the answer will be 8. Now with the identity integer being 1, if we divide 1 by 8, the answer will be 1 over 8. These two answers are not the same. Now let's try a different identity integer for the division operator and see what happens. Now let's select the identity number the identity integer as 5. Now let's pick a random integer. Okay, let's pick the number 30. This is our random number that we have selected from the number line. Let us see if this is an identity integer for the division operator. So to check this, what do we have to do? First, let us divide 30 by 5 and let's see the answer. 30 divided by 5 is 6. Now what is 5 divided by 30? This is the fraction 5 by 30. According to the identity property, when you divide 30 by 5, the answer should be 30 itself. The answer should be 30. Is the answer 30 when you are dividing 30 by 5? No, the answer is not 30, it is 6. Similarly, 5 divided by 30 is 5 by 30. It's not equal to 30 and it is also not equal to 6. Therefore, 5 is not an identity integer for the division operator. 5 is not an identity integer. Right? Or 5 is not an identity integer for the division operator. Okay, now let's select a different number. Let's select the number 3. Right, so let's select 3 as our identity integer. Now let's do another random number. Now let's take the random number 12. Right, let's divide, and our operator is still 12. Let's divide 12 with 3. 12 divided by 3. What is the answer? The answer is 4. Is it the same as 12? No, it is not the same as 12. Now if you do the reverse operation, that means you are reversing and you are doing 3 divided by 12. This gives you the fraction 3 divided by 12. Now 12 cannot divide the number 3. Therefore this fraction remains as it is. Now you'll notice you're getting 4 and 3 by 12. None of these numbers are equal to 12. Right? The condition in the case of identity is that the division of 12 by this identity number must be equal to 12 itself. No matter what number you pick as the identity integer, that number will never satisfy these equations for the division operator. Therefore, the division operator does not satisfy the identity property. Even if there was one number which satisfied this condition, that number would be the identity integer for division, but there is no single number for which that property is satisfied. Therefore, the division operator does not satisfy the identity property. You can use all kinds of numbers as the identity integer. You will notice that minus and division do not satisfy these relationships for whatever integer you pick as the identity integer. Therefore, the operators minus and division do not have identity. However, if you pick 0 as the identity integer, the addition operator satisfies these relationships. Therefore, the identity integer for addition is 0. Similarly, the identity integer for multiplication is 1. Now, what is the associative property? Associative property means that if there is an equation that has multiple integers but a single operation, then the result does not change even if there is a change in the order of the integers. What do we mean by this? What we mean is there could be many different integers in an equation, but the operation is just one. That means there could be 3, 4, 5 integers which are different from each other in an equation, but all of them have either addition or multiplication or subtraction or division between them. Now let's see what happens in that situation. In the case of an addition operator, Let us say we have these three digits 8, 3 and 4, and we are adding them like this. The 3 and 4 are added first because there is a bracket over them. What is going to be the result? 8 plus 7, which is equal to 15. If these brackets are moved around and they are placed around 8 and 3, that means you are doing these operations first, right? The operator addition is associated with 8 and 3 first, and then it is associated with 4. That is what is the meaning of this expression. Here the result will be 8 plus 3, which is 11, plus 4, which is again 15. Even in the case of multiplication, you will see the same becoming true. Even if you change the association of the operator, so that means here 3 and 4 are multiplied first. The multiplication operator is associated with 3 and 4 first, and then with 8. In this case the result is 96, and when you associate the multiplication operator with 8 and 3, and after getting that results, when you associate it with 4, the result is still 96. But that is not true of subtraction. 8 minus 3 minus 4 is 1, but 8 minus of 3 minus 4 is 9. The same thing happens to be true for division as well, right? 1 and 9 here are not the same. Even in the case of division, changing the sequence of how the operator is applied changes the result. So the addition and multiplication operator satisfy the associative property, but the subtraction and division operator do not satisfy the associative property. Now let's look at the distributive property. Distributive property means that if there is an equation that involves multiple integers and multiple different operators, the result does not change even if one operator is distributed over the other operations. Notice that this is slightly different from the associative property. The associative property was saying that the equation involved multiple integers but a single operation. But the distributive property says that the equation involves multiple integers and multiple different operations. So for example, look at this. Multiplication distributed over addition. This is the same as 8 into 3 plus 4. So we are taking an example. 3 plus 4 are in brackets. This is equal to 8 multiplied by, according to board mass, we have to do the brackets first. So we're doing 8 into 3 plus 4. 3 plus 4 is resolved first. This becomes 7. And 8 into 7 is 56. However, if you take this multiplication into the brackets, this is the result that you get. 8 into 3 plus 8 into 4, which becomes 24. 8 into 3 is 24. 8 into 4 is 32. And the answer is again 56. Now what happens if you distribute multiplication over subtraction? 8 into 3 minus 4. This, when you try to solve, becomes 8 into minus 1. 3 minus 4 is minus 1, which results in minus 8. When you distribute the multiplication over the subtraction, look at what we get. This 8 has been distributed to 3 and 4 by opening the bracket without doing the subtraction. So we have opened the bracket without doing the subtraction. So now we have 8 into 3 minus 8 into 4. This results in 24 minus 32, which is also minus 8. So you can see when you take multiplication and distribute that over addition, or take multiplication and distribute that over subtraction, the result remains the same. Therefore, for the set of integers, the multiplication operator can be distributed over addition and subtraction. Now let's look at addition distributed over addition. Here we have an example. 8 plus 3 plus 4, and 3 plus 4 are in brackets. This will resolve to 8 plus 11, because according to board mass you have to solve the brackets first, and the answer is 19. But let us say we distributed the addition over the addition. Now we will have 8 plus 3 within brackets plus 8 plus 4. See, this 8 has been distributed into the brackets. So we now get 8 plus 3 plus 8 plus 4. This becomes 11 plus 12. Right? This 8 plus 3 within the brackets resolves to 11. 8 plus 4 becomes 12, which is 23. And obviously 19 is not the same as 23. Therefore, addition distributed over addition is not possible. Similarly, if you tried subtraction distributed over subtraction, that wouldn't work either. And so on and so forth. So it is only multiplication that can be distributed over addition, or multiplication can be distributed over subtraction. Any of the other combinations, division distributed over addition or division distributed over subtraction, would not work. So for the set of integers, the multiplication operator can be distributed over the addition and the subtraction operator. To summarize, addition and multiplication satisfy the commutative, associative, identity and closure property. The identity integer for addition is 0 and the identity integer for multiplication is a 1. Multiplication further also satisfies the distributive property over addition and subtraction. The subtraction operator does not satisfy commutative property, associative property or identity property, but it satisfies the closure property. That means if you subtract one integer from another integer, the result will always be an integer. The division operator does not satisfy commutative, associative, identity or the closure property. So students, in class 7 in chapter 1, we cover integers. And what have we learnt? We have learnt the review of numbers. We have finished understanding what is the number line. We now know how to perform addition, subtraction, multiplication and division operators with integers. We have understood what is board mass, and we have understood the closure, identity, commutative property and associative property and distributive property of addition, subtraction, multiplication and division operators. I hope you enjoyed the class, and make sure that you do the practice exercises. Also, create notes for this chapter. This will come in very handy. Thank you everyone. Hope you enjoyed this class and hope to see you in future classes. Have fun.